All right, so on this problem, we're going to take the partial derivative with respect to x and then also with respect to y. And when you take the partial derivative, which is this other notation, you pretend like the other letter is just a constant. So I'm going to go ahead and first do the partial derivative with respect to x. So I'm going to do dx of this. And here, I'm going to multiply the exponent by the coefficient. So I'm going to say 12x squared and then reduce the exponent by 1. Now the y, I'm just going to treat it as if it is a constant. And then same thing here. So the exponent of the x is a 1, so negative 8 times 1 is going to be negative 8. And then if I reduce that exponent by 1, there's no x's left over, but I'm going to hold the y as a constant. Now I'm going to do the same thing, except for this time, I'm going to take the partial derivative with respect to y, and I'm going to hold the x's constant. So here I'm going to take the coefficient and multiply it by the exponent of y. So that's going to be 24 x squared, and then I'm going to decrease the exponent of y by 1, and I'm going to just hold the x's constant here. And then same idea here, so I'm going to multiply the exponent of y, which is 1, times the coefficient, so negative 8, and then reduce that exponent by 1, which eliminates the y. So this is going to be my partial derivative. And then I'm going to plug in these numbers here. So I'm going to plug in when x is negative 1 and y is 2. So everywhere that I see x, I'm going to put in negative 1. Everywhere I see y, I'm going to put in 2. So rewriting that, I'm going to get 24 parentheses, x is negative 1 squared, and then y is 2, and then minus 8. So evaluating that, I'm going to get 24 times negative 1 is negative 24, times negative 1 again is positive 24, times 2 is 48, and then I need to subtract that by 8, and I will get that my final answer is 40.